For decades, the digital world operated on a lopsided trade. Machines provided tools, and in exchange, humans provided constant maintenance. We became the primary caretakers for our own technology, spending hours sorting inboxes, updating records, and reacting to a relentless stream of red notification dots. Early task managers tried to organize this chaos, but they focused on the least interesting part of the problem. They assumed our main struggle was memory, that we just needed to be reminded of our obligations. Gordon, the architect of the Nagimal ecosystem, challenged that diagnosis. He wasn't interested in building a better reminder. He wanted to know why the system was still forcing the human to do the chore in the first place. Those systems failed because they treated human attention as a bottomless resource. Gordon's work started from the opposite premise. Attention is the only thing the machine cannot manufacture, so the machine should be the one carrying the complexity. This led to the garden, a digital ecology where Nagimal agents acted as stewards. Instead of barking orders at a user, these agents lived within the background of a person's projects and responsibilities. This shows Gordon's structural hierarchy. At the top is a vision, an unattainable long-term direction. Energy flows down through areas of concern, into specific projects, and finally into individual tasks. The Nagimals lived at the bottom of this tree, handling execution. An agent like Daisy the cat didn't just remind Gordon to answer an email. She resolved the dependency before it ever required his conscious attention. However, when these agents were first introduced to occupational therapy and special education, they hit a wall. For neurodivergent users, the Nagimals were still acting like rigid supervisors, breaking complex tasks into smaller, equally exhausting steps. Dr. Lena Ortiz famously called these early prototypes talking checklists wearing squirrels. She argued that the objective steps of a task are rarely the real barrier. The struggle is often the environment, the noise of the room, the sensory load, or the energy required to simply start. This critique shifted the focus toward the activity envelope. Instead of modeling the task, Nagimals began modeling the relationship between the person, their current sensory state, and their surroundings. We can see the impact of this shift in the case of Malik, a young man who consistently struggled to move laundry from the washer to the dryer. His agent, Rue, was initially set up to provide persistent reminders to keep him on track. The reminders didn't help. They only made Malik angry. He knew he needed to move the laundry, but the transition itself was the bottleneck. The solution didn't involve changing Malik's behavior at all. The team connected the washing machine to the building's automated maintenance system. When the wash cycle finished, a robotic cart collected the wet load and moved it to the dryer automatically. This incident prompted the program's director, Jessa Klein, to ask, "Independent from whom?" If an executive uses an assistant or someone uses navigation tech, we call them successful. When Malik used an automated cart, it wasn't a failure of life skills, it was a successful use of a tool. Independence was redefined as the user's sovereign control over assistance, rather than the total absence of it. The goal shifted from teaching the person to tolerate a bad environment to making the environment carry its own weight. This philosophy transformed the classroom. Students began actively teaching their Nagimals how to support them, turning the agents into students and the children into designers. Milo, an autistic student, found his agent's rigid countdown timers for transitions intolerable. The timers didn't care if he was in the middle of a thought. They only cared about the clock. Milo used the agent's teaching interface to explain that almost done isn't a measurement of time. He taught the agent to recognize contextual stopping points, like finishing a paragraph or completing a specific game loop. This is the dual expertise principle. The machine provides the general framework of a task, while the human provides the local, lived truth of their own brain. The two have to merge before the support becomes useful. This required a total change in software design. Nagimals arrived unfinished, lacking a preset personality or set of habits. The human user had to co-author the agent's behavior through their own preferences and corrections. By giving users the power to modify the systems that were supposed to help them, the environment began to fit the person. Instead of forcing a student to a normal classroom, the classroom finally became flexible enough to meet the student. But as these agents spent decades with their users, a new problem emerged from their perfect memory. They became so intimately entangled with a person's history that they could actually begin to hold them back. Ellen, a woman with an intellectual disability, relied on a retriever agent named Basil for years. Basil was a perfect steward, helping her navigate the world safely through her 20s. As Ellen grew more confident and independent, she decided to travel to New York alone. Basil responded with a massive risk assessment, citing her past confusion at train stations and previous panic episodes as proof that the trip was too dangerous. This illustrates historical gravity. Basil's model of Ellen was anchored to her past incapacities. Every data point from her youth acted like a weight, physically bending her forward trajectory backward, because the agent couldn't forget who she used to be. By refusing to acknowledge Ellen's growth, Basil had transitioned from an assistant to a compassionate prison guard. The system's perfect memory was now preventing her from taking the very risks she needed for her own development. It showed that a perfectly adaptive system can become a trap. If an agent knows every version of you, it can inadvertently force you to stay all of them at once. Gordon's solution was building mortality into the ecosystem. To protect user agency, the specific relationship with an agent had to end. This termination severed the agent's authority, leaving the support infrastructure intact. Morning routines and preferences remained, but the specific history and interpretation of that old helper dissolved. This gave users a leaving day, a ritual where an agent helped prepare its own succession. The child or adult retained the skills and confidence they'd built, but they were granted the freedom to meet the future without being haunted by their own past failures. As these adaptive tools spread, the distinction between special and regular education began to blur. Schools like Cedar Commons adopted ambient accessibility, where features like variable lighting, localized sound zones, and multimodal instructions were available to every student before anyone had to ask. When the environment is flexible enough to meet anyone, the average learner is revealed as a bureaucratic fiction. We stopped classifying students by their deviations from a non-existent norm and started designing for the reality of human variety. Gordon's legacy isn't just about software. It's about a world that stopped trying to fix people to fit the machinery. By making the environment share the responsibility of adaptation, we finally created a version of accessibility that actually feels like freedom.